Okay, welcome to Chapter 2. Chapter 2 is all about the Structured Query Language, SQL. By the way, we have another course offered at the university. It's a CIS4301, which goes into Structured Query Language a little bit further. So this is supposed to be just like overview, trying to get you started. We're not going to learn all the SQL commands in Chapter 2, just things for reporting data back out of a database. That's it. So learning objectives on page 46, they talk about understanding what an ad hoc query is. You could have a stored query that somebody else wrote for you, and all you'd have to do is just click on it. Or you'd have to write it yourself, which is what we're going to be doing, an ad hoc query. Retrieving data from just one table, that's pretty easy. Grouping data together, because sometimes you want to find the average or the sum or some sort of a grouping kind of operation. The use of comparison and logical operators, where first name equals Bob. And then retrieving data from multiple tables, which is something we're not actually going to get to in this one particular video. I've broken Chapter 2 up into chunks, because Chapter 2 has got a lot of stuff in it, and if you're not used to SQL at all, I want you to take it nice and slow and easy. I mentioned that you might want to consider an extra book. This is an SQL for Dummies book. It's a very good book. Again, like I mentioned before, don't get turned off by the name. It's actually a very good book. Okay, so let's begin. So the background, business intelligence. A lot of companies have lots and lots of data. Lots of data, but they can't do anything with it because they don't have the right kind of skills. So business intelligence, there are companies out there that just do business intelligence for a living. They'll descend upon your organization and tell you what your data says, which sounds a little weird to me. A canned query is a query that somebody else has already built. And then an ad hoc query is one where you type it out on the command line. We're going to be typing it out on the command line for quite some time. There is a GUI-based graphical user interface, a GUI way of producing, but quite frankly, you don't learn much doing it that way, so we're not going to do it that way. There's one called Query by Example, and again, those are cool, but not useful for learning things. It's useful for getting things done, but not in an education environment. So we're going to be using Structured Query Language, SQL, to write queries against the database. Okay. So one of the examples they have in the book is this thing called Cape Cod Outdoor Sports. Dun-dun. And so it's a database where they have online transaction processing, which means they can have multiple stores, or they can have internet customers in some sort of a mail order scenario, where it could be a device like a point of sale application, or it could be a web page, or it could be some sort of an application, and they all go to some sort of a database, and then it does its thing. Okay, so all the sales, whether it's at a store or internet or mail order or whatever, all go into the same system. So this is considered an online transaction processing, an OLTP, online transaction processing, which means your people are entering and querying the data nonstop. Okay, so a little bit more about business intelligence, BI, and data warehouse. We have a chapter coming up talking about this in a little bit more detail. So this is just to wet your whistle. So the components of a business intelligence. So you have your operational database that you own, and then you maybe have some other internal data. Maybe it's in a spreadsheet or something. And then you have some external data. Maybe you hired a company called like Amerisearch and provided you customer information. And then ETL stands for extract, translate, transform, and load. ETL, which means I pull the data. I don't want all the data from my operational database. I want to thin it down to, for example, I don't need to know every single transaction for a McDonald's at the counter. I could sum it up by the day, and that would be fine. I don't need that granular of detail. So extracting the data means I have less data to mess with. And then you have some sort of a database management system where you could tap into other data warehouses, and then you have these business intelligence tools. And mostly the BI users are not your average run-of-the-mill user. These are probably data analysts or, high people way up in the corporate structure who want to determine, for example, why are the sales of McRib sandwich not doing well in the Southeast? That kind of stuff. So you're doing a lot of what-if drills. Okay, one of the things to think about when you're talking about a data warehouse is if you're extracting all this stuff and putting in some sort of a data warehouse, you typically don't do this on the very same machine as your live database. And the reason is that you can tune a database server to be very responsive to that online transaction processing thing. So this guy has got some specific tuning to make this work really, really well. And it is the exact opposite of the things that need to be done to make this go fast. And so you can't really have both. So practically nobody, unless you just have very little data, nobody does business intelligence on the same server or even on the same machine. You just put it on another machine someplace. Okay. Typically, this is historical data, right? When you're doing this type of analysis, like where to put the next McDonald's store, you don't need live data. You just, historical data is just fine. And quite frankly, historical data could be read-only, right? Because you're not going to be making any changes to it. After you extracted all that sales data, you're not going to be going into those tables and adding rows or deleting rows or changing values, right? So there's some shortcuts you can do in a database if it's read-only. And then there's a term called a data mart. And quite frankly, this distinction between a data mart and a data warehouse is relatively small. Basically, what a data mart is just a very small data warehouse, okay? Like a single vendor you go to and say, hey, I need the data on where high schools are being built because I want my new McDonald's to be right across the road from the new high school, but I don't know where those are. So you hire a company to find out where all the new high schools are being built. So in this example of Cape Cod, this is what their Cape Cod database kind of sort of looks like. They have a retail order, and then they have every retail order could have multiple order line numbers. In other words, it's sort of like filling out a form. You know how at the top of the form is, I'm ordering something from Amazon. So it's got my customer name and my address and, the date and the shipping information, blah, 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 blah. And then I ordered 5 things on that one order. So 5 items. So that's what the order item is. The order item is those line items inside a single order. So a single order can have multiple line items. Okay, good. SKU data is sort of like their inventory. So it contains things like the description and things like the unit price and things of that nature. And then the buyer, in this particular case, they have people who are, salesmen kind of thing that are associated with buying the product. Okay. And then they have some other tables that are not linked. It is actually kind of unusual to have a table design that have orphan tables. In this particular case, they're orphaned for a reason, because they're historical. This is the historical 2020 version of the catalog, and here's the historical 2021 version of the catalog. And so it kind of makes sense. So those aren't live tables, so there's no need to be connected to the live database. Okay, cool. So continuing. The next thing they talk about on page 52, they describe this thing called the relational notation. I mentioned that in the last video where we were talking about Appendix A. This is very important that you understand what text-based relational notation is. All right, one more time. Here we go. I'm going to go to here. Whoop, that's not what I wanted to do. I wanted to go to the notepad. All right, I'm going to go in here and I'm going to say, student. And student's going to have a student ID. And it's going to have a first name. It's going to have a last name, etc., etc., etc. Okay? So this, if I do this in underline, which I can't do that in Notepad. I probably should have done this in WordPad or something. I'm going to fake it and make it look kind of funky here. So that, pretend like that's underlined. Okay. So underline means that's the primary key. So this is text-based relational notation. Okay? It's kind of important that you understand what this is. All right. There's an example on page 52. It consists of the table name and then parentheses. And inside the parentheses is a list of column names. A column name could be underlined if it's a primary key, or italics is the foreign key, or both, because they could be both. Okay. So yes, you're absolutely positively going to have to learn this. Okay. Now there's an odd thing about when you talk about a foreign key. If I have a foreign key, we call it a foreign key, right? But the thing that attaches to the other side of the foreign key doesn't have a name. You know, I would have called it, I don't know, a foreign key receptor or something. I don't know. But there's no name for the other half of the foreign key. Okay. So on page 54, let's start talking about the schema. Schema is a term used in database in lots of different contexts. So it's a little confusing because Oracle's use of schema, the word schema, is different than a lot of others. So if you're used to Oracle, schema in the Oracle world is sort of like your user profile. Okay, and it has not that much to do with your database. But what this is, if you had a list of these things, okay, these things, a whole bunch of these guys, that would basically be a collection of all of the tables, relational notations. That would be the schema. So if I gave somebody this, they could look at it and go, oh, okay, I see you've got 5 tables, and here's how they connect, and here's where all the primary keys are. It's a way of describing the tables. Okay, good. So we talked about the relational database design. One of the examples we had in a previous was an example where they had a choice between having one big table or 2 smaller tables. You guys remember that? Okay, and I could probably find that really quick. Here we go. I have one big table or 2 smaller tables. Okay, so the relational design is to use this technique over here where we actually have 2 tables. Okay, so how do you determine, how do you split up a table? Okay, I got one big table, and how do I split it up into 2? Well, the technique is called normalization, and we're gonna talk about this all the time in Chapter 3. So right now we're just going to broad brush tell you what it is. The technique from getting from the left-hand side to the right-hand side is normalization, but we'll learn more about that. And so then how do you stitch the tables together? Once I got these 2 tables, how do I return back to what I had before? And so that's a thing called joining, and we're going to be getting that in Chapter 2, but not the first half of the video. Okay, so on page 55, they start talking about the background behind the SQL language. Okay, so, you know, a lot of people like standardization, you know, like a standard procedure for doing something. So there are standard committees that meet and vote and say, this is, by God, what SQL, you know, from clause should look like. And here's what a select clause should look like. And they're very picky and make sure everyone has the right thing. The problem is, when databases were first built, like mostly in the US, they used the ANSI character set. If you don't know what that is, don't worry about it. Basically, it just means the US character set. And then when we took it over overseas, you know, to other languages, it didn't work well. And so one of the things we did is we changed it to an ISO standard, which is an international standard. Okay, that's better. And then the standards body would actually verify that the vendors were actually telling the truth. If they said, well, we adhere to standard number, 1, 2, 3, 4. They would verify. And then after 1996, they basically said, you guys just do your own self-certification. Really? So now a company can claim to be, compliant with what, I'm compliant with SQL, 2011 standard, and we just have to kind of sort of take their word for it because there's no formal procedure for determining whether or not they're lying. Okay, kind of crazy. And the standard was huge, and so they started breaking it up into smaller chunks so they could took too long to get the changes out, so they broke up one tiny little piece over here so they could get it out quickly, and another piece over here they need to be working on. Okay, so we're coming up on the 15-minute mark, so you guys know how this works.